Hi guys, so this is other stuff for the Scala workshop, functional oriented. So today we are gonna talk about uh, mono transformers, but I will try to explain you with an example. Let me share my screen. Can you see the screen now?
Yes, we can see your screen.
Cool. So I was mentioning it. We are gonna talk about mono transformer, but let's think a little bit about this real scenario that we could have. So, let's think in a application or piece of code that needs to find uh, a user uh, in a DB. So we before to start coding, always we try to design something, things like that. So we could have some issues. So the first one is the user may be or may not. Uh, and also we have to manage the access to the database. You know, also we have some issues there, network issues, user credential issues, things like that. So probably we will have using functional stuff. We probably will need to model this as using optional monad that mentioned last time. Optional an option color terms, the user, and the connection for DB to be managed using an here. Uh, this is the idea. So using the monads that we saw last time, we'll have to do something like this. I'm gonna define a type error just as an alias of a string just to do our code or readable. I'm gonna create a user definition. Um, all the fake class maybe connection. Create a method to user. Uh, so uh, coding just for demo purpose. That's all for here. We are gonna create a function to emulate the established connection. uh, 0. We will get error on the connection. Ah, for demoing real scenario, probably this could be a little bit more complex, but just for showing you. Uh, Nothing special here. This is the full program. So let's see. This could be it, you know, fake, thriller, doesn't matter at the moment. And then we try to do this. Remember, find user, or if you prefer verbose stuff, it's you want. So let's see the types. So now we imagine that we need to the ID by the user, not no whole object. We need the ID to do some operations. Important. So probably we will have this. This is so just include the type for this. Look, we have this monad either to manage two paths, the errors and the possible user that we have. That means we have one monad here and other here. So if we have to do some operation with the result that really matters, we should have something like this. We have here, if you check an unnested monad, user, then user form, have one new, and here this is an optional of user. That means we cannot have we don't have the properties for our user. That means we should have to do something like this. We have one for comprehension and we have other one just for try to operate with this value. This is as you can see a little complicated because we have to write a lot of code to solve that kind of things. Here is when monad transformer is a possible solution. So you can see a monad transformer as a kind of pipe between two monads. The idea is provide an external monad and an internal monad. We use as we have just one monad. That's the general idea. Try to um, join these monads in one, but something like this. So let's see the example. Uh, we are not going to implement our monad transformer because the implementation could be a little uh, weird, and you know that's not the idea. However, there is an library in Scala that cares about uh, functional stuff, pure functional stuff. They use an lambda calculus as a definition, as a concept, the same things that we have seen. So the idea is just try to reuse the more to use that stuff that means. So the library it's called CATS for category theory. But you can see in the documentation they use an a cat. Let's try to. This is the monad transformer that we are gonna use, an either T. So this is just a grapper with whatever context that we provide of either. That's the idea. So let's try to refactor using monad transformers. Only I will need to use another function just to compare something. That's smart. And we are gonna use this dimension. We need provide uh, a context that we are using is equivalent to this. And as we provide this context, we don't need to use optional in the type that really uh, want to manipulate. So there are a bunch of constructors, pure, parameter, right, lift f, things like that. Just is the idea. Just put in our pipe the the result that we want. So we can start. So remember, this is an another. We could use. So let's see the type for this in a moment. Now, at the moment, we don't have nothing defined as a context. Probably we'll get some. Oops, we'll get some non-compilation here. But it's just for showing you the types that we have at the moment. We have nothing at the moment, and a DB connection and the error. So the idea is, with that DB connection that we have at the moment, try to use the stuff that we have. So if we use a flat map as we saw previously, we'll need to return other identity. That's not the idea. This provides also other functions, such as there are a bunch. We are not saying all, just the more important, we are using the semi-flat map. So what's the idea with semi-flat map? Just return the type that we have within the external monad. That's the idea. We could do something like this. Here is verbose stuff just for showing you how it's working.
Giovanni, can you repeat what the semi-flat map will return?
Yeah, for sure. Let's see the signature. We have an external context. We have an monad, at the
Yes.
moment. So, but we don't want to return other iterative. That's the idea. You know, we want to return an optional from the user. That's
Yes.
this method. Okay. So if we use on a semi-flat map, we can return the type that we have as a context in our monad transformer.
Ah, okay.
That's the idea. Could be anything that we put here on a list or things like that.
Okay.
No,
Yes. Perfect.
that's
Thanks.
the user. So let's see, probably we need to. Let's see. We have from either. Let's see. So now we have this type. We have an option. The T, nothing special here. But now we are gonna pass to do this instead and using mono transformer. So I'm gonna write using for comprehensions. This is our real user. So we can operate the stuff that we need here. You see the difference? So we pause to use a nested mono and just using this grabber as a one monad. It's a kind of uh, pipe could be a good example for this. That's the idea with monad transformers. We have two monads for any reasons here, uh, as our small program says. We probably won't have a user. We have to keep in mind that we could receive a no label value, and we have to model how to deal with that. So probably we'll use an optional. And for manage the connection or things like that could be in a bad way, we probably use an either. It's just an example. Then we have to use all the stuff, and the idea is always try to do something any operation with this. That's the final idea. Send to the other microservice, whatever we need. So if we don't have any monad transformer, probably we'll have to deal with a bunch of extra code always just for try to manipulate our values, which is not fun. Could be really difficult. Try to think in this. That's the use cases for monad transformers. So we have in Scala, in CAT's library, we have an either T. We have also an option T. Could be an option as a wrapper, and within we could have other monad. We have a bunch of implementation that really could be really useful. So do you have any question up to this moment, or anything that you want to see different?
Giovanni, how do you manage the error in the version 2 of the find user by ID? Because I understand that you avoid the second for to just get the user, but in case there is an error, how do you manage the error?
Okay, cool. Let's for example, this could fail. We could get left. Yeah, why? That's you say if we get on a left projection, we are not able to do this. For instance, let's see here. If we get on a left projection here, we skip that piece of code. That no continuous compose with anything else that we need. That answers your question?
Yes, but if you want to get the error itself, you need another for to get the error
Okay.
string.
Probably we will get this projection. I mean, this could be. Let me try to. We just use the force for concatenate computations. So if you got a left projection or a non on an error or things like that, the computation won't continue happen. So you already have the effect here. So probably this is we have the option value. It just return the wrapper and our either. Okay, and we have this. We have some value, or we don't have anything else. If we have value, we actually can do something. This is an another as you see. And here we can get their right or is left. Probably if you need to do something with the errors, do something. But that's the idea. You have all the graph,
Okay. Yes.
and within you can start this. So cuts also provide us some way to use from B flat map or default. So the idea is we have two functions. The function that is when we have the correct value, right value, and the function that we don't have. So we can do by us using something like this or using this stuff. We have to provide two functions that I mentioned previously. That could be also the idea. Or they also have thinking in the problem that you mentioned. I know we want to use the right path or the happy path and do something, but they also have provided the left map. That's uh, check what was wrong, what kind of errors we have. They also have implemented that for us, which is nice.
Okay. So in the case, the first either will in line 68 will process the user, but if there is an error, this processing will be aborted, we can say, and then we can check the left. We should always check the left element in order to know if there was an error, right?
Right, correct. That's the idea. Don't rise the errors, just encapsulate as a types. We try to use some algebra behind that.
Okay, perfect. Thanks.
That's the idea. Good question. That's all that I have for mono transformers. So probably I would like to show you how to use a functional stuff for testing. We will see this in the next session, but the idea is how functional stuff provide us pretty interesting ways to do testing. So I don't know if you have seen something expression for all element that follows some predicate. We always have to do something like this. So we have on a for all definition, we introduce a predicate just for checking that if it's working as we need, and the result is a boolean, but the idea is here always be true. So there are a concept that is we have ways to generate random data, and then we can use the properties of that data. So for instance, we can check the always in assume if we add two integers, we always will have another integer, things like that. We start to thinking the properties that we have in our abstraction on in our models, and then try to figure out what rules we have. That's the idea. The concept is property based testing, and that's the idea. Provide an input random value and specify the properties that we have to complete. So things like that for all elements in our set of possible values. Do an predicate or an evaluation and check if is the result that we expected. Um, this is pretty cool because we have a kind of regression testing every time that we run the unitary test. We also are able to check edge cases and so other things. So that's the stuff that we will see in the next workshop, but that I just want to mention before to save time the next session. That's all for now.
Perfect. Thanks.
Perfect. Thank you.
Cool, man. Thank
Thank
you.
you. Thanks,
Thank
Giovanni.
you.
Bye. See you next session.
Okay. See you.